Hello, everyone. Good morning, afternoon, evening. Dear authors and invited guests, welcome to Technical Session 8B. Myself, Ashutosh Goel, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GIAS Classic LLP, it is my great pleasure to welcome you all to the 10th International Conference on ICT for Sustainable Development, ICT4SD 2025, Goa, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event is being held today in Goa, India, and the virtual event is being held through Zoom from 17 to 19 July 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations, and each presenter will be given 10 minutes for the presentation and 2 minutes for question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for the session, Dr. Archana Chaudhary. Dr. Archana Chaudhary is an associate professor. Dr. Archana Chaudhary is an assistant professor at Vishwakarma Institute of Technology, Pune, India. She has over 20 years of experience, including 4 years in industry and more than 15 years in academia. She has published several research papers in international conferences and journals. She's an IEEE member. His research interests include signal and image processing, Internet of Things, control system, and artificial intelligence and machine learning. I would now like to invite Dr. Archana Chaudhary to share a few words of encouragement with the attendees as we begin the session.
Yes, thank you, Ashutosh. Can you hear me?
Yes, ma'am.
Yeah. Very good afternoon to all the participants of this conference, and I'm sure that the work which is going to be presented will benefit one and all in the conference and also the publications. So, all the best and best of luck.
Thank you,
So, we
ma'am.
can proceed. Yeah.
So now, without further ado, let's start with the first presenter.
Yes.
First upon, I would like to call Sir Jishnu Prakash K to present his paper titled A Novel Approach to Mitigate Information Spread on Social Networks. Do we have you here with us, sir?
Hello.
Yes, sir, you're audible.
Okay. Let me just share my screen.
Sure, sir.
Is the screen visible?
Yes, sir.
So, good morning, all. I am Jishnu Prakash K. Today, I am here to present my research work titled A Novel Approach to Mitigate Information Spread on Social Network. So, coming to the problem statement, social media platform like Twitter help people share information quickly, but they also make it easy for misinformation and rumor to spread. This can confuse the public and even cause real world problems. Right now, it's hard to stop this because current method can't easily find and manage the users who spread these false messages, especially as online community which keeps on changing. In this presentation, we will explain why it's important to build a better system that can detect key users, track how rumors spread over time, and find the best ways to stop them early. Our goal is to reduce the spread of misinformation and make online networks stronger. So this is our proposed methodology. So we will be having our interaction-based data set. Then after which we will further go to the feature extraction. And then we will have the influencer score for each node in the community that I will explain for the slides. Then forming community based on this influencer score. Then the main two algorithm that we developed, which is our novel IDS propagation tracking algorithm and the target network disruption algorithm. Using these two algorithms, we will be able to reduce the misinformation spread within a social network or a community. So let me talk about my dataset, which is Higgs dataset. It's a popular Twitter-based dataset. It has over 8 lakh nodes and their interaction. There can be three types of interaction: retweet, mention, and replies, which happen in social medias. Each interaction include the timestamp also. So moving on. Here you'll see how this influences for calculation is being done. If you take a normal scenario, there will be different interaction. There will be different kind of interaction happening in social media. So if a rumor is spread and the connection of the immediate connections of the friends of that particular rumor spreader, then he try to retweet the current post, it will have more impact than mention or reply. So for these three interaction, we have given three priorities, which is highest priorities for retweet and lowest is reply. As you can see, 5, 3, and 1. And for each influencer node, the influencer score is nothing but the sum of its weighted interactions. Let me just show you. So here, if you see, this is a sample community which is formed using Inform app, and we filtered out to be each community to get a minimum node of 50 numbers. So if you look at here, there is a node D. There is a two type of interaction happening here, retweet and reply. So the retweet we have given the edge weight is 5 and the reply as 1. So the influence score for that current node is nothing but the sum of these two, that is 5 plus 1, 6. So moving on to the main algorithm, which is a novel based algorithm we developed, that is propagation tracking algorithm. Here you can see the algorithm steps, but I will just give you a quick run. The propagation tracking algorithm is designed to measure how quickly information, like rumor or a piece of misinformation, spread within a specific community on a social network. It begins by identifying all users in the selected communities and then determining the top 5 influencers based on their influencer score. These influencers are assumed to be the initial spreader, so their earliest time interaction are recorded. For all other users, a reach time is initialized as a infinity, which is that can be reached, indicating they haven't yet been influenced. Then we have a queue is created to process user based on their interaction time, starting with those who's received the information first. The algorithm works by iteratively selecting the user with the earliest time interaction from the queue and checking their connection within the community. If a connected user has not received or reached or can receive information sooner than the previously recorded, their reach time is updated and they are added to the queue. This process continues until all users in the community have all processed. Finally, the algorithm calculates the average reach time across all users, providing a measure on how fast the information spread happened in a community. This insight is critical for understanding information flow and designing strategies to limit the spread of harmful content, that is misinformation. So after performing this algorithm, we will be getting the adjusted propagation time. That is nothing but the time required for a rumor to propagate within the community. Then comes the second important algorithm, which is targeted network disruption algorithm. Once we have the top 5 influencing node, we will try to remove the influencing node and get the average propagation time. So more the propagation time, less, I mean, more time it take to spread the rumor. So the targeted network disruption is designed to slow down the spread of information by removing the most influential user in community. It begins by calculating the initial average propagation time, which tells us how quickly information spread in the community. If this time is below a certain threshold, the algorithm enters a loop. In each step of the loop, it identifies the top 5 influencer and remove them along with their connections. After each removal, it recalculates the average propagation time. This process continues until the propagation time becomes greater than the defined threshold. Effectively, it slows down the spread of rumor. Then the algorithm then return the final adjusted propagation time, showing how much the disruption has delayed the rumor spread. This approach help identify and remove key users who play a major role in spreading false information. So moving on. So after performing the second algorithm, you can see the propagation time for the same community has been increased. That is nothing but the time to spread the rumor has increased. So our goal to maximize the time to spread rumor has successfully obtained here. So these are some general working and visualization of the algorithm. This is a sample graph we have made. Let's say there are 8 node A, B, C, D, E, F, G, H. You can see the propagation time it taken. These are the top 5 influential node we got. Then after performing disruption algorithm, we remove the top 5 influential node from a community, getting only 2 node remaining and increased adjust propagation time. Hence, pointing out my idea of delaying the spread of rumor. So that's all from my part. I hope this would help society to be a better tomorrow. And thank you.
Uh, yes, so Jishnu Prakash, just go to the second slide.
Second slide. Just a minute.
Yeah, so second slide is problem statement, but you have not described what is the literature survey, what are the existing methods, and what is your novelty from the existing methods. So what is your literature survey? How others have done this work? You have come to a proposed methodology, right? So how have you come to that? There is no literature survey in your work.
Oh, okay. So,
Can you
so
justify with the proposed methodology what others have done? And there is no comparative analysis also with other methods. How can you claim those claims which you have done?
currently, the research work that has been done on this particular topic is based on the machine learning and the deep learning algorithm for identifying the rumor uh, spreading node, which is the identifying the node itself. So our novelty is nothing but we are just trying to make the propagation path or the propagation of the rumor as much delayed as possible. We are not mitigating the propagation of rumor. We are making the rumor takes long time to propagate. So this will be the connecting bridge between the research that had been done previously by other
Yeah,
professors or
but
other
you
people.
have not mentioned what is the research done. That's the point.
Okay,
Okay,
yeah, I got it. Yeah,
please make sure that you have added that in the research paper.
yeah, research paper it is there.
You have missed it in the presentation. Okay,
Okay,
no
okay, so
questions. Yeah.
okay, man. Anything else?
No questions further.
Okay, okay, ma'am. Thank you.
Thank you for your presentation, sir.
Okay.
Now moving on to our next presenter, I would like to call upon Ma'am Yukta to present a paper on the title AI and Fake News Detection. Do we have you here with us, ma'am?
Good morning, good afternoon, everyone.
Yes. You may present your screen, ma'am.
Is my screen visible?
Yes, ma'am.
So, good afternoon, everyone. I am here to present on behalf of my research team from Dronacharya College of Engineering. Today, I will be sharing on our research on AI and fake news detection. Now, the first thing that arises in everyone's mind is that why is this research important? So, as we all know that today's digital era, information is shared faster than ever, but not all of them is true. With the rise of the social media and online platforms, the fake news spread quickly, widely, and often unnoticed. This misinformation can mislead the public, influence election, damage reputations, and even endangers life during health crisis or natural disasters. That's where the AI steps in, as the traditional methods are too slow, manual, and limited to keep up with the scale and speed of today's fake news. So, The AI, artificial intelligence, and natural language processing can offer automated, accurate, and real-time solutions for the fake news detection. In the recent years, the internet has become the primary source of information for millions of the people. With the exclusive growth of social media platforms, online news websites, and instant messaging apps, information spread faster than ever before. This spread of the fake news can impact the public opinion, healthcare decisions, and politics. Some real life impacts of the fake news are during the year 2016, the US presidential election, the fake stories influenced voter perceptions. During the COVID-19 pandemic, the misinformation about the cures and the vaccine spread faster than the verified news. To detect them, there are some key approaches that are being used as follows. First one is the traditional linguistic approach. In, in traditional linguistic approach, this method focuses on analyzing the linguistic structures and the style of the context. Some key technologies that are used that are term frequency, inverse document frequency. It is used to measure the importance of the word in the document related to the collection. Post tagging, that is part of speech tagging. It identifies whether a word is a noun, verb, adverb, etc. That can help to understand the sentence compositions. And sentiment analysis. The sentiment analysis are used to determine the emotional tone of the statement. The next approach is the machine learning approach. The machine learning approach has the algorithm of the machine learning are trained to learn patterns in a labeled or the unlabeled diagrams. There are two major types. One is supervised learning and the another one is unsupervised learning. The supervised learning, this work on the labeled data. That means that the news should be clearly marked as real or fake. Some common algorithms that are used under the supervised learning are support vector machines, SVM, naive Bayes, and random forest. The another one is unsupervised learning. The unsupervised learning works on unlabeled data, which identify hidden clusters or the relationship within the data. The next one is deep learning. Deep learning approach. The deep learning has taken fake news detection to the next level. It uses the neural network. It uses the neural network that automatically learns complex and abstract pattern for the massive volume of the text. Some models are recurrent neural network RNN, which is best for the sequential data like text. The next method the next model is long-term short memory, LSTM. It is a type of recurrent neural network that handles long-term dependency and avoid vanishing gradient problem. The next approach is natural learning approach, which focuses on enabling machines to understand human learning. The the most impactful development in natural learning process is the use of the transformer based models, including bidirectional encoder representation form transformer, that stands for BERTs, Robota, XLNet, and T5. These models use self-attention mechanism to understand word in context, both forward and backward, helping them to grasp the deeper meaning of the text. Lastly, we have the graph-based learning approach. Unlike text-only method, this technique analyzes how information spread and how sources are interconnected. Some algorithms that are used are node-to-vec. This is used for representing the nodes like users or articles as a vector, and Transi. Transi is used for knowledge graph embedding. Let's now look at the few significant studies in the domain and what they reveal about the capacity and the limitation of the AI models for the fake news detection. The first one is Aladli, having a presentation. This research was done in 2019-20. The dataset that is used is liar, iOS, and fakes. The methodology for this is it also contributes in 2000 and in also contributes COVID-19 fakes, a multilingual Twitter datasets for the pandemic misinformation. The accuracy for this is liar 62%, iOstat 96%, fakes 58%. The limitation for this is that no use of the deep learning is used. The small sets are vulnerable to the overfitting or the underfitting. The next one is Kumar and Asta. This research was done in 2020, having a dataset of Twitter of about 300 tweets, fake news net about 1056 instances. The methodology uses machine learning and deep learning models. The accuracy of the data was that the machine learning model achieves an accuracy of 73 to 88%. The deep learning model show a lower accuracy of 57 to 58%, and the limitation was that the deep learning model underperform on the dataset and failed to generalize to the larger one. The next one was Chaudhary and Acharji. The dataset used was the fake job posting dataset having 18,000 samples and the liar dataset having 12,836 samples. The methods used was the traditional machine learning classifications and generative algorithms. The accuracy for this was the fake job 97%, liar 60%. The limitations for this was that the liar dataset fine gradient label post challenge. Here are some advantages of the categories that of the models that we have used. The first one is the machine learning models. The machine learning models are very simple and easy to implement.
I think you can go to your proposed methodology because this is a repetition. You can go to your proposed methodology.
The machine learning, the AI in fake news have some future directions also, that it is very useful in data quality and diversity. The one of the biggest challenges today that is the lack of the high quality diverse data set. In the future, we need to develop a large scale balanced and the multilinguistic data set that include different languages and misinformation types. The next one is multimodal learning. The multimodal learning
just a minute, Yukta. So just go to your title, please. So it is AI in fake news detection, right? So you don't have any proposed methodology. So is it a review paper you are publishing?
Yes, ma'am.
But I think you should add some at least you should add some block diagrams and the pipeline of what is deep learning, how deep learning is used and machine learning is used. Okay, so you can conclude now, no problem.
Okay, ma'am.
Yes. You can conclude in 2 sentences.
Yeah, sure, ma'am. As we conclude this presentation, it is clear that the fake news is one of the most pressing challenges in today's digital world. So the models that are used is deep learning method that overperform the traditional machine learning approach where when the sufficient data is available. The second is pre-trained embedding that improves the semantic understanding and help reduces reliance. Thank you. Ma'am, any questions
Okay.
about?
Thank you so much for the presentation, Yukta.
Thank
Do
you.
we have any questions for her? Or no? So we'll be moving forward to the next presentation. So next up we have Praful Sambhare with the paper title AI Enhanced Fashion Assistant featuring Image Recommendation Glambot. Sir Praful, are you here?
Yes, madam. Good
Yeah.
afternoon. Yeah. Okay. Let me share this.
You can share your screen and go ahead with the presentation.
Yes, yes, sure.
Yeah.
I hope my screen is visible.
Yes, it's visible.
Yeah, thank you. Uh, Good afternoon, ma'am. Uh, Title of my paper is AI Enhanced Fashion Assistant featuring image recommendations. And the system is used to call Glamboot. It's a review paper. The authors are listed here on the slide: Praful Sambare, Abhay, Nitin Chaudhary, Sahil Rana, and Atharva Rana. These are the contents I would like to explain here: introduction, literature survey, gap findings, motivation, problem statement, scope and objective, proposed system architecture, design, models, software tools, and conclusion. Introduction. Glamboot is an innovative AI-powered fashion assistant designed to develop personalized outfit recommendation for any occasion through real-time conversation. It offers tailored advice not just on clothing but also accessories, color coordination, as well as footwear. As Glamboot learns your unique style preferences over time, it refines its suggestions, ensuring they align with your taste. Additionally, Glamboard enhances the user experience by generating visual representations of recommended outfits, helping you to easily visualize and perfect your look for any event. Glamboard also revolutionized fashion advice by offering real-time AI style. Feature of visual outfit previews, it ensures you can confidently envision and perfect your look for any occasion. Then I would like to add some literature survey, some prominent literature survey.
Sorry to interrupt. So your slides are not moving.
Is it visible now?
No, just the first page is visible.
Okay.
Yep. Yeah. Yeah, now it's moving.
Okay. Okay. The first author, Eldermal Dash, examines factor influencing consumer fashion preferences that highlights the importance of personalized recommendation system in enhancing the online shopping experience through swift content filtering and tailored predictions. After that, Peria ETL explores the integration of customer models and recommender system in fashion retail supply. Then Lee et al. Addressed the challenges in close image retrieval using a ResNet-based model with a cluster triple loss function. And one more author work on this, Lee and Rong et al. Develops an interactive retrieval system that utilizes user Natural language feedback. This system enhances retrieval accuracy through feature fashion and similarity metric learning, showing improved performance compared to traditional methods. The next move to the gap finding. Gap finding slide is visible, ma'am. Hello. Personalization techniques gap need to deeper exploration of advanced personalized strategies that adopt an individual user preferences. Then multimodal data integration gap is limited research on integrating user images, text and context for improved recommendation. Then user interaction and feedback. The gap is insufficient focus on real-time user feedback mechanism to refine recommendation dynamically. Then cultural and contextual sensitivity. The gap is need for system that consider cultural influences and regional fashion preferences. The next is sustainability consideration. Lack of studies on incorporating sustainability metrics into fashion recommendation. Then let's discuss about the motivation. I hope motivation slide is visible to everyone. Personalized experience. Customers seek tailored fashion recommendations that reflect their unique style and preferences, which Glamboat aims to provide. E-commerce growth. The increasing volume of online shopping necessitates a solution that simplifies decision making, helping users navigate their choices more effectively. Then sustainability focus. With rising environmental awareness, Glamboot can promote sustainable fashion options aligning with customer values. User engagement. Current system often lack integration. Therefore, Glamboot will enhance user engagement through real-time feedback and interactive features, as well as cultural relevance. The project will or the system will focus on cultural as well as regional factors in the recommendation, ensuring they research with some user identities as well as cultural identities. Then let's move toward the problem statement. The aim is to develop Glambot, an advanced chatbot for online fashion shopping, leveraging natural language processing for text analysis, providing product recommendations, and enhancing user engagement. Extend its capabilities to support image-based similarity search, voice search, as well as diversify the dataset for an comprehensive and intuitive shopping experience. Then following is the objectives for the system. Expand the dataset for broader image diversity. Integrate voice recognition for hands-free search capabilities. Then implement image recommendation for similarity searches. Then improve user interface for seamless image and voice-based interaction. Optimize query analysis for accurate and efficient search result. Scope of the scope of the system is personalized recommendations, that is to develop algorithm that analyze user preferences to provide tailored fashion suggestions. Interactive chatbot implements a user-friendly chatbot interface for real-time fashion advice and assistance. Image-based suggestions will provide. Utilize computer vision technique to recommend outfit based on your user uploaded images. Then this is what the proposed system architecture you can see. I hope the figure is visible. Here there are different layers. If I talk about the layer number one, that is input modalities, user can provide input via text, image, or voice. Then second, feature extraction layer. Text input is processed by digital bird and it's an NLP model to understand fashion related queries. Then image input is processed by.
I think it's not visible and you are not into slideshow mode. I cannot see
Okay,
that image.
actually, actually, what happened, ma'am? If I make it full view, that is slideshow view, it will not move on. So
Yeah, but that's because you're not sharing the screen. You're sharing only your presentation. You should share your screen. Okay, it's
okay,
fine. Go ahead.
okay. Should I go now?
Yes, it's okay. Go ahead.
Okay, okay. I hope my proposed system architecture is visible.
Yes.
Yeah, let's talk about the layer number two, that is feature extraction layer. Here, text input is processed by digital BERT, that is natural language processing model. If the input is in case of image, it will be processed by ResNet 50 to extract key visual features, that is pattern, colors, and styles. And if suppose the input is in the form of voice, it will be converted to text using automatic speech recognition, that is ASR, then passed to digital BERT. Then next move to the next layer, that is hybrid recommender engine. It combines deep learning for content-based matching and collaborate filtering for user behavior analysis. Then learns continuously
So
from
where is the
user.
hybrid block over here in the proposed methodology? Where is the hybrid block? Hybrid recommendation you have said now. So where is that block in this method architecture?
Actually, I'm talking about layer, madam, layer. The middle layer, or we can see a middle.
So you are not talking about system architecture right now.
Yeah, I'm talking about the middle layer, that is
So
text
do you
input
have that
layer.
diagram?
Yes,
Do you have that diagram?
no.
Okay,
See
go ahead.
what?
Go ahead, please. Yeah.
Okay. Then design or algorithm or techniques. Here we are using collaborative filtering, user base and atom base that recommend atom based on the preferences of similar users or similar
So
atoms.
please don't read this slide. Go ahead. Just explain how you have done it.
Okay. Then there is a content-based filtering. Content-based
I'm
filtering will.
asking you not to read the slide. Please move on to the next slide.
Okay, fine.
Please go ahead.
Oh,
Next slide.
okay.
Have you got any results and discussion?
No, ma'am, it's in review paper.
Okay, fine. Conclude.
Okay. See, I can conclude this Glambot, a survey paper. Glambot presents a novel AI-driven fashion assistant that integrate text, then images, as well as voice inputs using advanced model. For example, we can use the digital bird, ResNet 50, as well as ASR to deliver personalized fashion recommendations to the user. Uh, it can even features a hybrid deep learning and collaborative filtering engine to make some improvement or innovations in the e-commerce websites. This is how I would like to conclude the Glamboat.
Okay, fine. No questions.
Okay, thank you, madam, thank you, everyone.
Thank you for your presentation, sir. Now moving on to our next presenter, I would like to invite Ma'am Shrishti Sakore to present a paper on the title Blockchain-Based Examination System. Do we have you here with us, ma'am?
Hello.
Yes, ma'am, your voice is audible.
Yes, so Shrushti, I need to ask you whether is this a review paper or you have done some proposed methodology?
Ma'am, we have done the proposed methodology.
Yeah, please go ahead.
Is the screen visible?
Yes, ma'am.
Okay. Good afternoon to one and all present over here. Myself, Shrishti, and I'm here to present our project blockchain-based examination system. So, before we understand why exactly we require blockchain for examination system, first let's understand what are the issue with traditional examination system. So, the first is the single point failure, which means in traditional system, almost all the data is deployed on a single server. If this particular server is hacked or fails, then the entire system collapses. The next is the operational overhead. The physical handling, printing, and distribution of the paper requires a lots of manpower and logistics, which not only increases the cost overhead but also requires a lot of management. Next, there is also a tampering risk as many people are involved in the cycle. So there are chances of paper being modified, and this brings us to the next point, that is lack of visibility. Even if the paper is modified, it is not possible to track and trace exactly who has done the changes and when has the change been done. So all of these issues make the systems less reliable, and there are high chances of modification being done in the question paper. So these are the issues which are currently existing with the examination systems. So now coming to the how blockchain solves the problems. Firstly, the as we all know, the blockchain is a decentralized system. So there is no one single central server which will, if which fails or hacks, then the entire system will collapse. It's not like that. The entire data is distributed across various nodes. So this makes it highly reliable. Also, there is smart contract, which are the core of the blockchain systems. Now, smart contracts are like the rule book, which mentions who can access what and who is authorized to access which part of the system. So, and this is automated. So there is no manual intervention required. Once the smart contract is set, it will handle all the further things. Next, traceability. Since blockchain logs each and every actions, like who has accessed, when it has been, like in the blockchain examination system, whenever a paper is uploaded on the system or whenever the paper is retrieved from the system, all of these activities are logged. So there is traceability, and it helps in audit trails. So these are the reasons why using blockchain in examination system is highly beneficial, and it solves the current problems that exists. Moving on to the roles and responsibility, there is a admin in our system who is responsible for adding the superintendent and the teachers. Further, the superintendent is the entity in the system who is responsible for request generation. Whenever there is a examination being conducted, the superintendent will provide all the requirements, like for which subject the paper is to be set, what is the paper type, like for which semester, which department, whether it is a regular paper or a KT paper. All these requirements will be provided and a request will be generated. Now, all the teachers who have expertise in those particular subjects and are registered into the system for that subject, those teachers will see a request generated on their dashboard, and other teachers can upload the question paper accordingly. Now, these question paper are further stored into the IPFS, which I'll be explaining in a short while. And the smart contract is basically for controlling all the access, checking the roles and records on the blockchain. Now, moving on to the architecture diagram. Firstly, whenever the user logs in, they are connected to a MetaMask. Now, MetaMask is like a key that helps perform all the blockchain related operations. It is like a signature or a sign. It is a digital wallet, basically. So the user interacts with the web system, which consists of front end and back end. Whatever the user requests will be seen in the front end, and the results will be seen on the front end, which is built using React. The requests will be processed on the back end. Back end is connected to smart contract. We have written the smart contract in a language named Solidity. Now, we have the smart contract is deployed on the Ethereum network. But to deploy the smart contract directly on Ethereum network, we will need a full node, which is complex and is not cost effective. So what we have done is we have used Infura tool. Infura is like a bridge between the smart contract and the Ethereum network. So what it does is it helps communicate or deploy the smart contract on Ethereum without requiring a full node deployment. And further here, the external services refer to the database and the IPFS. IPFS is interplanetary file system, a distributed file system. It's like a cloud storage, which helps store all the question paper that are submitted by the teacher. And the MongoDB is the database that we have used for deploying the system. Now, talking about the workflow. Firstly, the superintendent will log in and generate the request for a particular subject or a paper. Then this request will be visible on the teacher's side. The teacher can submit the paper. Now, once the paper is submitted, it will get uploaded on IPFS. So IPFS will generate a hash for that particular paper. This hash is a unique hash, which will be unique for each and every paper that is uploaded. Now, whenever the superintendent tries to retrieve the paper that is uploaded by the teacher, the hash that is stored in the blockchain. This is the hash that the teacher has uploaded on the IPFS, and whatever hash is generated initially, it is stored on the blockchain. So now while retrieval, again the hash is generated. So is this hash similar to the hash of the uploaded paper? Both of these things is checked. If the hash is same, it means that the paper is not tampered or there is no modifications that have been done. So this proves the security and reliability of the paper, and the superintendent can download the paper. Further, the smart contract is basically used for request validation, instant access, role-based, and immutable record keeping. Like I have explained before, it will give role-based access, like teacher are responsible for whatever things, only those things will be accessible to teachers. Superintendent will be accessible whatever is supposed to be accessed by him, and as soon as they are verified, they will be instantly given the access. Immutable record keeping again refers to the traceability point, which means that whatever records have been made on the blockchain, it will be whenever there is any action performed, the smart contract will emit an event, and this event will be stored on the blockchain, so it's very easy to see who has done what changes exactly, thus helping in accountability. So these are the advantages of the system. Like it helps improve efficiency by not relying on a single server. Fraud detection and security, as there is hashing used and the hash changes even if there is any small modification done. Transparency and auditability, and the data integrity. These all are the benefit. To conclude, I would like to explain the gist of the entire project. Like it offers a secure, decentralized approach to exam management system. We have combined a smart contract, IPFS, and blockchain to ensure the decentralization and to provide the access control. And this just reduces the administrative overhead and provides the transparency. So that's it from my side.
Yes, Shrishti, good. Very nice. No questions.
Okay, thank you.
Yes.
Thank you for your presentation, ma'am. Now moving on to the next presenter, I would like to call upon Ma'am Sabrajit Kaur to present her paper on the title Energy Consumption in Wireless Sensor Networks Using Fruit Fly and Ant Colony Optimization Algorithms in Heterogeneous Environments. Do we have you here with us, ma'am? Do we have anyone else from the team with us? Since there's no response, we'll be moving forward with the next presenter.
Yeah, we can
Next.
give them a chance if they join later, okay?
Yes, ma'am, we will give them a
Yes.
chance once again
Yes.
at the end of the
Yes.
session.
Yes, yes.
Next upon, I would like to call Ma'am Kodari Madhvi to present a paper on the title Eyes as Interfaces, a novel eye tracking mouse cursor system. Do we have you here with us, ma'am?
Yes, sir.
Okay, ma'am.
Is my screen is visible, sir?
Yes, ma'am, your screen is visible.
Thank you. So good afternoon, everyone. My name is Madhavi. I'm honored to be here to present my paper behalf of my teammates. So our title is Eye as an interface as a novel eye tracking mouse cursor system. Our project title will explains that it mainly focuses on hands-free solution for enabling seamless digital environment for the interactions, and it also encourages people who are with mobility disabled. We know there are many people in worldwide. It helps them to work independently, and it eliminate the traditional inputs like keyboard, mouse, where it utilizes the computer interaction by using OpenCV media pipe and Auto key, and it helps the physical disabled persons to track the screen by using their eyes, and the main idea is to help them to work independently and closes the accessibility gap in the digital system by using cursor system interfaces. So this is the survey we have been done. Like the paper publication of 2020, which displays that by using mouth opening, it will be difficult to work for so much of time spending. We cannot work by using open mouth. So I want to overcome this. And also the year of publishing paper 2022 is by like published by based on the head poses, but I believe that a person cannot be posed uh, like in a same direction. It can be moved, and by this it can reduce the accuracy at a distance. And publication year of 2022 is based on the gaze direction estimation. It is like it is depends upon the data quality. If it is not quality data, it cannot measure the accurate performance by using eyes. And the publication of 2024, it uses the real-time detection, but it is over time greater than 2020 seconds, but limited in brief of dynamic usage scenarios. So our proposed model is like it is interacts with the input layer and control layer and user interaction. Basically, in input layer, the system begins with a webcam which captures the real-time video, and this form the video which is captured, it is forms into the input and forward into the control layer. In control layer, it handles for the eyes gesture detections. Based on the gesture detection, it will perform the user interface based on their given actions of their eyes. And this is our proposed model. Here we can see whenever the person uh, sit behalf of webcam, the face will be detected. If it is not, again it will be redirected to detect again. Once the face is detected, then eyes will be detected. Once the eyes will be detected, it is processed into the process model where it helps in working the process. In first of image resolving and counter detection, it is like it is based it is a technique where process the images or video real time. and based on the pixels with intensity values, it will set the one value based on the recorded real-time video. Then after thresholding, counter detection algorithm will be applied to identify the boundaries of the object within the binary images. Like it will analyze the typical involving finding the counters like eyes, eyelids and pupils. Based on that, it will move to the vector analysis of eye landmarks. It is a phase that correspond. It will identify the landmarks are usually detected using facial landmarks detection and also processed into linear mapping, where it helps to transform the mathematical into the eye features to perform the actions, like based on the eye aspect ratios, whether they are in, like based on the eye aspect ratio, it will perform the actions like they are uh, including gestures like blink detection or moving next, like that. And automation will helps us to redirect to the screen to perform actions. Once the process is done, the cursor movement will be happen. If the user get fatigued, we can turn it by using keyboard shortcuts. Otherwise, we can continue our process. And next, this is our eye gestures using. So here we can see the images too, whether our eyes are detected by using the real-time capture video. Like it will identify the face, then including around the eyes marks, then it will helps to track the eye movements and gestures like blinking or looking directions. Once the directions are focused, then it will helps us to focus the circle in the eye like pupil we can see in the image. By checking the position, it will detect if the user is looking left, right or up and down. By measuring the distance of upper or lower eyelids, MediaPipe can detect the blinks and quick reduction in vertical eye size indicating the blink. So once the eye movements or blinks are detected, it will work on. This is our system workflow. Here we can see, as I explained before, once the webcam is started, it will capture the video and process into the for eyes detection. If it is detected, it will move to the trace for eye marks, eye landmarks, or else it will retry capturing the frame and calculate the gaze detection and maps the gaze to the screen coordinates. Once the screen coordinates is mapped, it will perform the actions based on the user gestures. So our main system design is to help the people who are physically not disabled. And as we can see, the webcam is, if it is not detected, it will represent on the screen the face or eyes are not detected. However, we can perform accurately. Like if webcam is successfully located, it will capture and process the work. And our project helps also provide the user privacy and security. Like whenever the it capturing real-time video, it will not record any personal data or store it. It just utilizes the video and point the gestures and perform the actions. And here we can see the output screenshots. As here in first figure, we can see it will not detect the toy as they have eyes and eyes which is in pupil. And in second image, we can see system recognize the face and eyes of the user. It will ignore the second person. It will only works on single person. Here we can see the diagram that second person was ignored by that system detection. This is the one of the screenshot I have want to share. Like here we can see I round up. The cursor is pointing here as we can see underlined. And once I perform the blink detection, it is open to the GitHub pages. And result and discussion. We have been discussed with by testing different quality webcams. Here we can see if it is.
Ma'am, this is a gentle reminder that 9 minutes have been completed.
Yeah, let her complete. It's fine. Go ahead. Madhavi, please go ahead. Yeah.
Okay.
Yeah.
Okay, ma'am. Here we can see the result and discussions. Like based on the webcam quality and lighting quality, this is our accuracy for our application. I prefer good quality camera can perform better accuracy, but it is okay for not well good cameras. It is also perform good, not that much bad. We have worked so much with different quality cameras of our friends also. Based on that, we have given accuracy percentages.
Oh yes, one question here I would like to ask is the
Yes.
laptop cameras. What is the quality? What is the
Our
webcam?
laptop camera, ma'am.
What is the quality and what is that accuracy? Do you have
Ma'am,
you?
our laptop camera is 720 pixel.
Oh, okay, so it will give little less accuracy in
Yes, ma'am.
dark
Because
mode.
yes, ma'am, my laptop is older camera.
Okay,
So,
okay, good.
okay, ma'am. So I want to conclude my application. So it is mainly focuses for the physical disabled person to provide them independently working nature, like by eliminating the use of mouse keyboards. This technology is especially beneficial for, as I mentioned, individual people, physical disabled, and enhance their ability to interact with digital environment. So for future work, we can also integrate with for multiple people, like multiple monitor setups and also voice commands. And also we can integrate with for mobiles. That's all, ma'am. Thank you. Do you have any questions? You can
No,
ask.
no question. I've already asked. Thank you.
Thank you, ma'am.
Yes.
Thank you for your presentation, ma'am. Now
Thank you.
moving on to our next presenter. I would like to call upon Sir Kailash Agarwal to present his paper titled Heart Failure Prediction with Explainable Artificial Intelligence Towards Trusted Approach, a comparative analysis of black box and transparent models. Do we have you here with us, sir?
Yeah.
Okay. You may present your screen, sir.
Yeah. Yeah. Is my screen visible?
Yes, sir.
Yes. So our topic for the research is heart failure prediction with explainable AI towards a trusted approach. So in today's world, artificial intelligence is gaining a lot of importance, but we don't know what is actually going inside AI. Like, why is it giving this prediction or that prediction? So our research is towards that, and that could help us in building the trust in AI. So this is the outline of my presentation. This is our introduction. So we have taken a case of heart failure, which can be reduced if we have an early prediction and an accurate prediction. So we have seen that there has been a lot of work done regarding this using other ML models, but ML models will give you high prediction rate, but they can't interpret it. They are not interpretable. You can't understand why the certain prediction was done. So our goal is to combine high performing machine learning models with explainable AI to such extent that the predictions are transparent and clinically useful. So we know failure is a major global health issue, and using machine learning we can detect it very early on, and but the detection is only half the problem. The other half is to interpret it so that uh, you are able to understand why certain prediction was done. In current machine learning models, they act like a black box. You just give them the input and you get an output, but you don't know which input parameters are important and which are contributing towards your prediction. So this is our problem statement. We are trying to apply explainable AI models to enhance the interpretability. So this is the related work that has been done in the field. So as we know, there have been a lot of machine learning models that have been used for heart failure prediction. There have been Ansible methods and hybrid models for that. One major work that is going on is AIR, which is being developed by NHS. So basically, it is AI for risk um, calculation they do, and they are able to detect the disease, and they are going into real life testing for that as well. And then we can use SHAP and Lime, which give us the interpretability of the model. They tell us more about the features and the factors that have contributed towards the particular prediction in global as well as the local prediction as well. So we have done a tree-based and non-tree-based comparison, and we have used SHAP and permutation importance to explain the model. So when we tried testing it out for, so this is the SHAP plot for the research that we have done. These are the features, and this is their importance that has come up. So we used a Kaggle dataset, which had features like related to heart indicators and other symptoms and age and all the other. So these are the features that we were using, and this is their distribution. So we can see there is a equal distribution in age and cholesterol data and the max HR data, and we can see we have a couple of binary data as well, like we have distribution of fasting BAs, the sex data is there, and the exercise engineer data is also there. And these are some of those binary data variables that we have. So we trained a few models, like we trained SVC linear, we trained SVC with an RBF kernel, we did some hyperparameter tuning, but SVC linear gave us the best accuracy and AUC ROC curve. We tried decision tree also, we tried XGBoost, we tried random forest, we tried logistic regression as well for the non-tree based models, but SVC linear gave us the best accuracy and AUC ROC curve as well. This is the AUC ROC curve for the SVC model, and we got an accuracy of 0.93. So SHAP is used to measure the local and global features that contribute towards a particular prediction. And permutation is a different method that evaluates the impact of feature shuffling. So basically what SHAP does is you get a feature importance graph for your uh, variables that you have used. So this one is saying ki ST slope up has more feature importance as compared to resting BP, because we have ST slope value up has more SHAP value than resting BP, and this is the order in which the factors are important. So while a doctor is trying to work on a particular case, they can try focusing on these factors more rather than compared to other factors which don't have much higher feature importance. And what permutation importance does is it tries to corner a particular feature, and it increases and changes its values rapidly and checks the impact on the final output that is done, so as to understand how much importance is to be given to a certain feature. So we used SHAP and permutation to compare and evaluate both the methods to see if we are getting similar variables that get the same amount of feature importance. So this is a plot for SHAP cases where the particular candidate had the heart issue. So as we can see, ST slope up, ST slope flat have higher importance as compared to something like resting BP or resting ECG normal. This is similar for the negative one as well. These factors are more important. So we got to know this from the SHAP values. These factors are important and these factors are very low impacting, like resting BP and resting ECG normal. When compared to the feature importance part of permutation, we can see the factors which have a negative impact as well, like age. So as age goes up, it is more towards the person might have a heart disease or not, or max HR. And the gender also doesn't matter much because both of them have equal weightage, as this doesn't affect the research part. So clinical relevance for this can be key. SHAP outputs can support the doctors and their AI collaboration and help them to justify for each prediction using SHAP local. And this would help to promote trust in AI assisted diagnosis. I would like to conclude my presentation by saying that SVC offers best accuracy, but it is not interpretable like other ML models. If we use decision tree models, then it becomes a case of if-else statements, which is more interpretable, but we don't get that accuracy that we get from SVC. Combining SVC with SHAP or permutation makes it more explainable towards the general public that these factors are that are affecting your disease. And explainable AI can help us bridge the gap between performance and trust. These are my references.
Yeah, okay, fine. No questions.
Yes. Thank you.
Thank you for your presentation, sir. Now moving on to our next presenter, I would like to call upon Sir Omkar More to present his paper titled Mental Health Management with Emotion Detection Using OpenCV. Do we have you here with us, sir?
Yes, sir. Am I audible?
Yes, sir, you're audible.
So we have two group mates with us to present the presentation. Can I share the screen?
Sure, sir.
So is the screen visible?
Yes, sir.
So our topic is mental health management with emotion detection, and I have two group mates with me. So yes.
Hello everyone, I'm Janvi Maske, and as Omkar mentioned, did a project called as Mental Health Management with Emotion Detection. The basic agenda of our project is to help people who have mental issues. As we know that there are growing mental problems for people, and everybody is seeking for help. And our platform helps them our platform helps them to get this help. So our platform has mental health management thing with emotion detection. So when a user comes on to using our platform, they can check their we can check their facial expression. On the facial expressions, we can detect what different things that they can do to help them with their mental issues. So our platform is both for the users and newly practicing psychologists in their new field. So it's a free platform which helps people suffering from such diseases. Omkar, next slide, please.
Okay, so hello everyone. Myself Sanika. I'll be explaining our main objectives behind this project. So our main goal is was to develop a real-time emotion detection system, which uses deep learning. Uh, we basically analyzed and detected emotions in which we aim to provide the practical insights for the overall nature of the well-being. So we integrated it using a user-friendly interface for emotion detection and mental health support. So in this we had features like appointment scheduling for the psychologist and for the user. Uh, yeah. So next we have the key features. Next slide. Okay, so yes, the main features in this project included real-time emotion detection, where users receive immediate visual feedback according to their emotions. There's also a therapist booking option, which makes it simple for users to reach out to the professionals. Additionally, if certain emotion signals a possible mental health issue, the system can identify this and guide users with relevant resources. So, in this, if a emotion is detected like sad, angry, happy, or neutral, more than one type of mental health issue is reported from which a particular therapist can be booked. So yeah, moving forward. This is the tech stack used. We majorly used Python, Flask, HTML, and CSS.
These are the two models that we have used. First one, where we help, where we can it is used for detecting the facial expression of the individual. For example, its smile, its eyes. On this facial detection facial emotions, we can detect what exactly they're going through. As my groupmate said, smile, anger are the particular niche that we are using for it. And then also we have used a second model called as Keras model, in which we have used CNN in it, where CNN helps us to identify the facial expression and give an accurate prediction, so that they can book a therapist easily from our website. So these are the two models that will help us to understand what our user is going through. Next slide, please, Omkar.
So this is our proposed system. First, the image is captured by webcam, and by hair cascade model, the face is detected, and pre-processing step is done. The image is pre-processed, and emotion is classified by CNN model, and the detected emotion is displayed on the screen. If after that the user want to book a therapy, then he can go to the booking section. If not, the system is ended. So this is the working. First, the face is detected by hair cascade model. We can also upload real time, means we can also upload images, and by real time capturing of our face, that can also be done by face detection. And after that, pre-processing step takes place, where the face is detected and converted to grayscale. Its size is of 44 by 44 pixels. Then emotion is classified. For this, CNN model is used. So there are 7 emotions we stated: sad, happy, angry, and other emotions are classified by CNN model. After that, insights and inputs. The At last, uh, all the all the therapist booking, receipt generation, and that is shown in last section of the website. So this is our output. Here we can see, uh, after the classification of, means you are happy, sad, angry, we can book therapist according to that symptom. And this is the screenshot of appointment has booked, and this is appointment confirmed, and we can return to home. So future scope is that we can use, means integrate audio and test for facial expressions, which will improve the emotion detection. And also we can train the model on larger data set for better accuracy improvement. And so yes, we can conclude that uh, first we have done real-time detection using Keras model and CNN model. After that, the all the insights are shown like emotions, happy, sad. All the We can book the uh, therapist for that, and at last, uh, the web shows that uh, how, means appointment is booked, and yes, we can upload images also.
Thank you for your presentation, sir. Are there any questions?
Questions? Good. It was well presented. Yes. Go ahead.
Okay, thank you.
Okay. Now moving on to our next presenter, I would like to call upon Sir Ayush Patil to present his paper on the title Sleep-Driven Mental Health Prediction, a multi-channel CNN approach using wearable sensor data. Do we have you here with us, sir?
Hello. Hello,
Yes, sir.
is my voice clear?
Yes, sir.
So I'll be presenting on behalf of Ayush. My name is Siddesh. Uh,
Sure,
I'll
sir.
start the share. I'll share the screen.
Okay, sir.
So is the screen visible?
Yes, sir.
Okay. So I'll start. Good afternoon, everyone. My name is Siddesh, and I'm going to present on the research topic sleep-driven mental health prediction. We have used a multi-channel CNN approach and use sensor data, variable sensor data for this. So to introduce the topic, mainly mental health patients often are undiagnosed or are diagnosed late. This is because mainly due to the reliance on subjective methods. Patients are often asked to self-report their symptoms, which can be influenced by their mood, memory, or even stigma. Furthermore, access to trained mental health professionals is limited. We recognize that sleep is a fundamental pillar of health and its patterns are profoundly affected by our mental state. Sleep disturbances are not just symptoms and critical biomarkers. By using the sleep data, we build a system that is not only objective but also scalable, offering a way to monitor mental health discreetly. So objectives were to develop an AI-based system capable of accurately detecting mental health conditions with initial focus to depression. We used data collected from variable sensors during sleep. We have designed and implemented a robust multi-channel CNN. The key here is multi-channel. Instead of looking at one data stream, our model simultaneously analyzes multiple physiological signals to capture a more complete picture of person's health. So for literature survey, past studies have used variable data for mental health prediction. They have used metrics like sleep count, sleep duration, traditional machine learning. However, this often required manual feature engineering and relied on broad data. More recent advanced field they have used heart rate variability. This demonstrated the granular data, but it was any model, meaning it only looked at one data stream. So our approach is to use multiple CNN channels simultaneously, like for heart rate, blood volume pulse, electrothermal activity. This allows the model to learn from the complex relationships between these signals, creating a accurate picture of person's physiological state. So for methodology, this is our architecture. First is the data collection layer. So we collect the data from various sensors, which gives us the heart rate, blood volume, electrodermal uh, data from the sleep. So why the data from the sleep is being considered? Because if we took this data during the day, it can be the changes can be not because of the person's mental state, but due to other reasons also. But when the person is asleep, the changes will be mostly because of their mental state. So that's why this data during the sleep is being taken. This data is then cleaned and normalized. We use some data augmentation to make sure the graphs which we generate can be used for training our CNN model. The next part is then we feed this graph to the our CNN models. So we tried 3 CNN models here. One is the multi-channel CNN, second is the multi-channel ResNet, and third is multi-channel efficient net. So the dataset used for this project was Dream T150 dataset. In this, the sleep data from 150 individuals is taken. The data set is ideal as it contains synchronized and multimodal physiological data from participants during sleep. We use signals like heart rate, blood volume pulse, electrothermal activity. This data, so after the data collected, we cleaned the data. The raw data was cleaned to handle any missing values and or artifacts that are common in real world sensor recordings. So when the data is collected, it might be raw. So we have to clean it, ensuring the data quality. Then we convert this data to graph. This is to use the CNN models, which can detect the changes in the graph, leading to the accurate prediction for mental health. These graphs are then fed to CNN models. So the resonate model is model which uses multi-channel variants. We fed the spectrograms for HR, BVP, and ADA into the model. So this is how the graph for a blood volume pulse will look like during a duration of time. Such graphs will be fed to the models. So this is the custom CNN model we used. In this model, the the training accuracy was between 60.5 to 65.8%, and the test accuracy peaked at 68%. This result is significant. It suggests that approach of processing sensor data in parallel channels is effective. The multi-channel ResNet was a stable model, consistently delivering an accuracy of 56.7, but its stability was valuable. The multi-channel efficient net showed high performance, peaking at 63, but it struggled to generalize. So the best model we find out was the multi-channel CNN. It had the high test accuracy of 68.3. This system we have developed offers clear advantage as it operates continuously during sleep and provides objective data, moving us from purely subjective assessments. To conclude, our research successfully demonstrates that a multi-channel CNN can effectively predict mental health status from variable sensor data collected during sleep. While the accuracy is quite low for now, we can see a clear path ahead. Future work will involve training on larger, more diverse data, incorporating breathing data, and ultimately working towards getting validation from clinical staff like doctors. That's all from my side. If you have any questions.
So yes, very nice. So I wanted to ask whether this data set is already publicly available or you have created your own data set.
So this data set is publicly available, but it's quite limited, the amount of data.
No, you showed me the graph, right?
So the graph is generated from the data set.
Yeah. So it is this data set. What I feel is missing in your presentation is a data set description, which should cover how it is acquired.
Okay.
Are you getting? So it is sleep data, you can understand, but how it is acquired using the watch or using
Yes.
ring.
So
That should be
currently
there in the dataset website, maybe.
Yes. So we
You have,
only focused on the machine learning part of the
yeah, I
project.
understand. But since you're working on a data, the machine learning is the next step, right?
Yes.
If you don't only read your data properly, then how you're going to do the learning part?
Yes.
Okay. See, I'm not saying this is a perfect information, but you should have more information on this as a person,
Okay.
like if you're working on the project. Okay.
Yes.
Yes. Okay. Thank you. So Ankita, are you there, Anisha? I think we should move ahead.
Yes, sure, ma'am. Thank you for the presentation.
So I think we don't have the next the person who is remaining is the energy consumption. Just call out for them if they are there, and then we can proceed.
Yeah, the next presenter is Bhumi C. Parekh with the paper title Stress Detection Using HRV as a Biological Marker. Sorry, a research study based on machine learning techniques. Bhumi, do we have you here? Any of the co-authors of the paper are available?
Who is this Aditya Srinivas?
I guess no one is there, so we'll be moving forward. We previously had an absentee named Sarabjit Kaur. Do we have her here in the meeting?
Excuse me, ma'am.
Yes.
Yeah.
I think
Yeah.
Anisha.
I am Aditya. I'm Aditya. Actually, I'm an absentee from the previous session. I couldn't able to make out.
Yeah, right. So he was not able to present in the previous session. And yeah, so we do have an absentee in this session, so we can take yours in this one. So if the session chair allows, ma'am, can we take his presentation in
What
the
is this
session?
topic, but what is this topic?
I'll share the details with you and I'll share the flyer as well.
It's okay. Let him present it. Just
Okay.
yeah.
Okay. So Adit, you can present here.
Yeah. Yeah. Thank you. Thank you for giving this wonderful opportunity. So my voice is audible, ma'am?
Yes. Go ahead. Make it in the presentation mode.
So, good afternoon, one and all. My name is Aditya Srinivas. So, my concept is developing a CNN model, which I call it as a Rebecca for effective lung cancer classification on a histopathy images. I'm presenting behalf of all authors in my paper. So what is the key issue that we are focusing on today? So when you see any pre-built model or any model that ever exists, it is designed for a specific task and it can't be used as a general purpose model or a target specific model for any such a given task. For that example, we have taken a histopathy images. Histopathy is a type of imagery in a medical science through which we image.
Are you changing the slides by any chance?
Yes, I have changed the slide, ma'am.
The second slide. We are on second slide, right? The
Yes.
problem statement. Yeah. Please go ahead. Yeah.
Yeah. So that's what a histopathy image is a type of imagery, such as like when you take an MRI, you will get a DICOM image. When you take a tissue image, that is called as a histopathology image. It is a very color dominant, such that no existing models, such as like VDJ16, RASNet, MobileNet, any models will struggle to classify this type of data. And thus, there is a need for lightweight and a specialized CNN which only works on this type of histopathology images. So this why do we require histopathology images in the first place is lung tissue cancer is one of the trending reasons in the cancer, and there is a low survival rate of under, if it is detected under 5 years, there will be a survival rate, else it would take a very severe cuts. So that's why detecting a cancer at a tissue level under before it going to a stage 3 or stage 4. Stage 3 or stage 4 is very important. That's what we are focusing on today. So this is our data set. We have took 7 different classes, 7 different type of cancers. One is in lung especially, and one is it in colon. So in lung cancer, we have different 5 classes. In colon cancer, we have 3 classes. As you can see from our images, they are very color dominant to a magenta or a purple. If you given it to a regular conventional CNN models, they will eventually fail because it is very specific color driven approach. So that's what we have took 750 images of 200 from 250, 250, 250 from each class. And we have used augmentation technique as our data sample is very less. So we have used augmentation techniques and made it as a 15,000. And we have proposed our own CNN model, and we compared with already existed models which performed better at that point of time. So that was this is our proposed CNN model architecture. We have used 5 CNN layers. We have used very simple strategy over here. We started with a basic feature extraction that we further worked out with to a complex thing. So, and when our model is trained, we have a low inference time of 17 milliseconds per image. That's what our model was able to achieve with that much amount of low resources. So this is a comparative analysis. So when you come to a domain specific, such as like a histopathology or a DICOM image or any single color dominance image, we have taken 3 models here. One is our own, which is Rebecca, 2 are VGG16 and West950, which are very moderately acceptable models. And we have used a GPU for training, and we have handled everything as the same. So when the VGG works with a larger amount of data set, and it is a very humongous model, which is unable to pick this type of features at this much low sampling size. So it took 18 milliseconds. When we given 100 images batch test to each model, VGG scored -26 because VGG is designed to classify CFAR RGB type of images. So definitely when a single color dominance image is given, it will struggle to perform. But RASNet at the other point of time performed great, moderate when it given us an inference time for a single image is 21 milliseconds, and it has scored 84 out of 100. But when you come to Rebecca, Rebecca took the most less amount of time, which is 17 milliseconds, and it achieved pretty much the score of 90. 90 successful predictions out of 100 images that we have only batch tested. So what is the conclusion of this, or what is the application of this? So 70% of survival rate depends on in a cancer case with an earlier detection. So clinical throughput and detecting cancer or detecting any some sort of malignance at the initial stage is very crucial. So we need a device, we can integrate our model with edge deployment such that we can able to deploy this type of application into rural areas, such that no pathologist or expert pathologist, if there is no expert pathologist also, we can able to identify a patient with a cancer. So tested on only lung cancers, what is our limitations and future work? We have only tested for few samples, and we have only tested for 5 cases, which we can extend, and we need to increase our data variance also. So we can extend this work to a breast cancer or a prostatic cancer, and we are in a process of developing an edge devices where this model inference or model will run on the NVIDIA Jetson on a Raspberry Pi, or it sits after this imaging viewer. So when you take this histopathology images, it will be viewed on a computer kind of thing, or a simple computer. So it will be attaching to this computer, and it will be able to identify whether this person, or whether after the test, after the
Yeah,
image is
fine. No problem. Yeah. Please go ahead.
so that's the conclusion
Yeah,
when we
go to your
compare.
results and discussion table, comparative analysis.
Yeah.
Yeah. So here, why you have written accuracy low, moderate, high? How can we validate? You should put, you have implemented this on your own in Python
Yes,
or yes, right?
yes, we
So
have, we
you could
have.
have got the accuracy in numbers out of 100%, right?
Yes,
So
ma'am.
why this representation here like this? Have you put the same thing in the paper?
No, man. We
Then
have
why
put
you put
we
it
have
like this
this
here?
graph.
That's not correct. You cannot validate that it is high unless you put it in numbers, right?
Yes.
Yeah. Okay. No questions
That's my
further.
bad. That's my bad. Anything else, ma'am?
Thanks a lot for the presentation.
Thank you.
Now we have our next presenter present in this session. Bhumi C. Parikh with the paper title Stress Detection Using HRV as a Biological Marker, a research study based on machine learning techniques. Bhumi, you may present your screen and
Sure.
start with the paper. Presentation. Yeah.
Am I audible?
Yes, you're audible.
So, a very good afternoon, madam, and my other participants. My name is Bhumi Parikh, and I am going to present my research paper, which has the title that is stress detection, which uses heart rate variability as a biological marker, and it is based on machine learning. So, an introduction about my work, which I would like to give. That depression is very much common in today's society. And basically, there are instances where it is not that much uh, that it is not that means it's not that much serious. There are some type of mood swings which are occasionally. So in that case, we call that type of stress as an acute stress. But sometimes it happens that this type of occasions and this type of instances are becoming quite gradual, and it affects the health in many ways, like in the form of sleep disturbances and digestive problems. Then it needs the cure. We need to prevent that stress, and it is known as the chronic stress. So, reason for depression is the inability of the human body to give a flight or a fight response, and this response is generated by the nervous system. And therefore, I have used machine learning algorithms like k-nearest neighbor, decision tree, naive Bayes, and support vector machine, and obtained an accuracy up to 99 percentage. So, going to the next slide. First of all, what is the role of biological indicators? So, I would like to say that apart from heart rate, there are other biological indicators also, like temperature, then blood volume pressure, that is the blood pressure, our skin conductance, that is the sweating, and also these biological indicators are responsible to some extent. But amongst all these biological indicators, I have considered heart rate as the important indicator. And specifically in heart rate, also I have considered heartbeat. That is the heartbeats which are generated, uh, and how their variation is found, and that can be depicted from an electrocardiogram, that due to the variation in the RR interval, there are chances that the linearity and the non-linearity of the graph is obtained in the ECG, and on that basis we can know whether the person is happy or sad.
So I have used a Wizard dataset, which is a multi-model dataset, and it contains HRV parameters. There are around 64 HRV parameters, out of which some are linear and some are non-linear. I have come to the conclusion that the non-linear parameters are more appropriate in giving the depiction of the presence of moods, that is happy or sad. So three classification is done, and there are three classes, that is baseline, depression, and happy, that is amusement. In the literature review, I have included four criteria, and this criteria I have also included in my paper, but it is not in the form of a table. I have curbed the things in a one title, that is one title of the literature review consists of biological markers of stress. Second consists of machine learning techniques. Third is the use of wearable devices, and I have annotated all the citations of the paper which are related to that, and also the hybrid models. So, in a very brief way, I would like to explain that as per the discussion previously, also there were the biological markers responsible, and amongst that biological marker there is also the electromyograph. And this electromyograph, just as the electromyograph will detect the brain activity which is caused because of the chemicals in the brain. Now the serotonin and there are cortisol, these hormones are responsible for keeping the mood and for governing the activity of the brain. So because of the generation of abnormalities in the brain, that is also one of the factors for depression, and that abnormalities can be known with the help of fractal dimensional techniques like Higuchi cats and other algorithms. So that is and apart from that, the blood volume, pressure, temperature, these all are the biological markers, skin conductors, which are responsible for some or the other way they are responsible for stress, and I have annotated it in my paper with suitable citations. Secondly, machine learning techniques will act as a non-invasive tool. So, whenever we are developing the ML model, at that time it does not affect the human body. It's a non-obtrusive way where we feed the data in the machine learning model and train it accordingly, and get the accuracy from that model using suitable algorithms. Third attempt can be made with the help of wearable devices. This data set which I am using is using two types of wearable devices, that is Raspberry and Empatica E4. Both of these variable devices they are chest and wrist. They extract the data from chest and wrist, because basically heartbeat is linked to the chest and our wrist, that is the pulse. And from these variable devices there are other types also, like Samsung gears probe and gyroscope, and all these types of devices are also responsible for collection of data. And fourthly, there has been the usage of hybrid models. So this is basically when we are extracting textual data set, that is Twitter data set, or any type of data from social media. It can be in any language, like for a Chinese data set it was Weibo. Then there are the use of deep learning models, CNN, that is a convolution neural network model, LSTM, that is a uh, this long short term memory, plus RNN. So all these types of models have been used for the detection of stress. And apart from that, for a more filtered way of obtaining the results, there has been the usage of activation function, that is a multi-dimensional attention layer network, that is used through the with the help of the activation function. So all these models have been used, and I have also obtained the accuracy that by using this data, the whatever data is available data set, and the data available in this data set, when I am applying to the LSTM plus SVM model, I get less accuracy, because it works more with textual data set compared to the numerical data set. Therefore, I have collected the tweets from the Twitter dataset and trained in the LSTM model and obtained a good accuracy. But the same thing when I'm doing.
Sorry to interrupt,
Yes,
but your slides are not moving.
yes, ma'am. Is it visible, ma'am?
Yeah, the literature review slide is visible.
Okay. Uh, so that is the concern that the same data set is not available with Twitter. Sorry, with the same data set is not usable with the type of machine learning algorithms. And that is the about the literature review. And again, here I have prepared a separate chapter for biological markers of stress, that is the EEG, electroencephalography. And that data is analyzed in MATLAB, and use of ML classifiers is done. Secondly, in the literature review, whatever I have spoken right now, I have demonstrated it that how the machine learning is a non-invasive tool, and marking of various types of algorithms like decision tree and random forest, they are used for this particular type of detection, as well as sensor data are also used. And I have also used appropriate citations where I find the annotation of this type of data. And the use of wearable devices is also there. So ECG sensor is used according to the citation number 4. This means that those devices which are non-obtrusive to the body, which a person can easily apply on the skin, and it does not cause any type of harm, can be used for stress detection. And the development of hybrid models like the CNN and LSTM based RNN. Basically, the main aim to use the combination of LSTM with RNN is to remember the previous states, as recurrent neural network is remembering the previous states, and DNN is a deep learning network which uses we can use the activation function, and accordingly create we can create one type of a model. And in this particular hierarchical attention transfer network, there is a use of encoders, and along with that the vocal data set is used, that is the AVEC. And with that vocal data, using the machine learning classifier, the results are obtained. And also the 10-fold, that is the value of case 10, in the 10 iterations the data or the vocal data is bifurcated, and results are obtained. So, in my particular research work, what type of methodology and techniques I have used, that I have shown. First of all, the data set which I have used, the description of that. Afterwards, how I have identified the features from that data set which are more prominent for causing, which are more prominent to give results of a person whether depressed or not depressed. Third is extraction of features from that particular data, that which features I can use as a independent feature and a dependent feature. And then I have shown the comparative analysis of the various ML algorithms which I have used. So the data set, as I have told, is a multimodal data set, which is a Wizard data set, and it collects the data from wrist as well as chest, and bifurcate into three classification. There are three types of condition in this data set, that is baseline, stress, and excited or amusement. Now I have identified the features, and for that I have found that the heart rate characteristics have various types of uh, there are differences in the features. Like there are some features which are linear, like heart rate mean, heart rate median. These are linear features. But when we plot something, or when one variable is dependent upon the another variable, or there is a regression type of methodology, in that case standard deviation 1, standard deviation 2, and the frequency features are more prominent. So I have identified that, and afterwards I have extracted the features in a way like there has been the use of three classes. There are three class labels in the data set, that is baseline, stress, and amusement. So basically I just want to know whether a person is stressed or not stressed, so I again converted that into binary classification, that is two classes, where there are only two classes, that is depressed and not depressed. And accordingly the entire I have normalized the thing and converted those particular labels into using a label encoder. I have converted it to numerical values and used the train test method split, and the ratio is 20 is to 80, and found that this type of results. And I found that decision tree outperforms as compared to other algorithm, because it is based on a recursive approach, and in my data there is no such no such recursive approach. It has a less it has less variance, and though the data consists of up to 11 lakh of records, but the variance is less. There is no hierarchy, or there are no subclasses that will work, or any type of complex data structure, because a decision tree generally works for that. So in that case I have found out that decision tree outperforms, and I found that for the nonlinear structure I'm getting more accuracy, like in the support vector machine, both for two class, that is depressed and non-depressed, and for the three class, that is stressed, that is baseline, amusement, and stressed. I have got that support SVM gives more accuracy, and thus this is how I have figured out.
Sorry to interrupt, ma'am, but
Yes.
you have completed the presentation time limit. Could you please conclude your presentation?
Yeah, sure. Why do we require to detect stress? So basically, there should be one type of an awareness thing, that there is something like that, and if there is a thing, it needs to be prevented. And again, there are some ethics and privacy, that though we go to the hospital or any other counseling place, but at that time, the individual should be comfortable with the diagnosis, and it should not be against his or her wish. As well as if the data set we are using some publicly data set, it should be from a recognized site or a recognized journal. It is our duty to authenticate that data set, and so that is the ethics and privacy concern. And overall I would like to conclude that my research study is based on state of the art results, which consist of biological markers, sensors, and hybrid models. And apart from this, I am also using different types of data sets, and with that data set also I have tried to classify the stress parameter by taking HRV as a prominent parameter, and found the accuracy. And my future work will include to collect data with some case studies of doctors, and also clinical reports, clinical records, and analyze it with the help of novel models. Thank you, and this is all from my side. These are the references.
Okay, no
All.
questions from my side. I think we can conclude the session now.
Okay, ma'am.
Okay, sure, ma'am. Thanks a lot for the presentation, Bhumi.
Yes, welcome, ma'am.
Yes. So I think all the
Yeah, so
papers
with
have been
that,
done. Yeah, I
yes,
think
ma'am,
all the
please.
papers have been done, right?
Yes, yes, we have completed all the presentations, and we only have one absentee, that is Sarabjit Kaur.
Yeah, right.
And she's
Okay.
not here in the session right now as
Yeah,
well.
right.
So we'll
She,
be closing the session now.
yes. So we had a good session with around 10 papers for the virtual room 8B. In that we had four review papers, and then we have a few papers which have good technical depth, And I guess all the authors have really enjoyed the sessions and the technical discussions. Okay, so with this, I conclude the session.
Thank you so much for your word, ma'am. We'll be concluding the session now, and I sincerely thank all the authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for you all.
Hello,
And we, on
ma'am.
behalf of the whole
Hello,
team,
ma'am. Good afternoon. Ma'am, I haven't
yeah,
presented my paper yet, Mr. Datu.
could you please let me know your paper ID?
That is 297.
Sorry,
297. Paper ID
297.
297. Yes, ma'am. I was actually scheduled from 3:30
And
p.m.
are you aware of the virtual room?
Virtual B.
8D or 9D?
Wait, ma'am.
I think I will log out
I'll,
because I have
So
another
maybe you
meeting.
can join the next session and we'll take your presentation there if we have any absentees there, right?
Yeah, I'll be logging out, Ankita. No, what's
oh,
your
wait.
name? Yeah,
Mr.
Anish.
No,
Datu.
yeah, no issues, ma'am.
Yeah, because I have
You
another
can join the
meeting.
next session and we'll take your presentation there, if that's fine,
Wait.
yeah?
Wait, ma'am. I'll check on my email.
Sure.
Actually, on the session proper is I just click on the site, and yeah, this is virtual room letter B, ma'am.
Yes, this is virtual room B, but we have to check which session is allotted to you. Could you please let me know in the chat your paper ID and your paper title?
Okay, for a while, ma'am.
Yeah, till then we'll conclude this session and we'll take your presentation in the next one. I'll schedule it accordingly, right?
Okay. Ma'am, my paper ID is understanding the factors influencing online classes in general education. Wait, I'll chat here on the chat box my title and then the paper ID for a while, ma'am.
Your paper ID is 297, right? Yeah,
Yeah.
that's your session is 9B and it's the next session we have.
Okay.
So you have to
Thank
join
you.
the next session. Yeah,
Okay,
thank
thank
you.
you.
Yeah, and so regarding the information, all the presenters would be getting their digital certificates through email within 2 working days. And further, all the papers have already forwarded to the Springer. The publication will be live within 7 to 8 months. So kindly cooperate with the team of ICT4SD 2025. I'd also like to thank our session chair. And with that, this is a token of appreciation to the chair, Professor Archana Chaudhary. Thank you for your presence, ma'am. And now I'll just take a snapshot of the conference to end this session. Can you please turn on your cameras? The remaining participants, I'll just request you to please turn on your cameras. Yeah. Thank you. Thanks a lot. See you in the next conference. Yeah. Thank you.